All right, welcome back. So part 2 of my recording, right? So you guys heard Rosie give her big send off with the bark. Now she's actually eating, so hopefully she's quiet for this one. We're moving to lesson 13.3. So actually, we only have 2 more lessons after this, 13.4 and 13.5, and then we are done for the year. Crazy stuff. All right, so we're going to find the derivative, and we're going to find the derivative using the product rule. So what happens is they're going to give you 2 functions, like y equals, and it's going to be 2 separate functions, and they want you to find the derivative, okay? So it's kind of like this, all right? You have 2 functions. Let's say f of x times g of x, all right? So this is the way it's going to go. I'm going to say it, and then I'm going to say it again. To figure this one out, you do the derivative of the first times the second plus the derivative of the second times the first. All right, ready? Derivative of the first times the second plus the derivative of the second times the first. You ready for it? Derivative of the first times the second plus the derivative of the second times the first. All right, you ready for it? All right, letter A. Here we go. So we want to find the derivative. Now we're leading you through, and we're telling you to use the product rule. Whoops, here comes Rosie again. Give me a sec. Woohoo, Rosie, go ahead. Okay, let me get that all situated again. You have no idea what I have rigged to make these recordings. It's kind of like MacGyver. All right, so here we go. All right, we're going to take the derivative. Look, this is your... nightmare. Here we go. This is your first function, x squared. This is your second function, x plus 2. All right, so... the derivative of the first, all right, the derivative of x squared, remember you drop it in front, 2x, and then it becomes to the first, so just 2x. So the derivative of the first times the second function plus the derivative of the second. All right, we have x plus 2. So remember, this is just 1x, so it's going to drop to a 1, right? And then the derivative of any constant is going to go away. So it's 1 times the second guy. So I'm going to read it again because I think I might be stumbling on my words a little bit. All right. Derivative of the first times the second plus the derivative of the second times the first. Okay. So you kick in your rule and then you clean it up. All right. So I get a 2x squared plus 4x plus 1 times x squared is x squared. So your derivative, let's see, 2x squared and x squared is 3x squared plus 4x. And you're done. That's your y prime. Okay, not too bad. I am going to slide this over a little bit. So here we go. Let's look at the next one. All right, we got letter B. All right, derivative of the first times the second. So I'm going to just slide over a little bit. All right, the derivative of the first, that's going to be 4x to the first plus 5, right? Drop it in front. And then derivative of 5x is just 5. So derivative of the first times the second plus the derivative of the second, so that's going to be 2x times the first. 2x squared plus 5x. All right, so what happens is, and it's funny, I was talking to my boss about derivatives, and he just said, like, calculus is just a really high-end algebra class, and I couldn't agree more, because this is just annoying algebra right now to clean this up. Now, you're going to have to double distribute here, so that if I double distribute, it looks like I'm going to get a 4x cubed plus 12x plus 5x squared plus 15. And then when I distribute here, right, I'm going to get plus 4x cubed plus 10x squared. All right, so now I just got to clean it up. So y prime is equal to, all right, I see a 4x cubed and a 4x cubed. So 8x cubed All right, I see 5x squared and 10x squared. That's 15x squared. I see just a 12x. And then just a 15. And you're all done. All right, so, you're probably like, well, why do I have to do this? Why can't I just multiply these all out and just use the power rule from before? And to some degree, you can. But what happens is it turns out to be tedious, especially if you have, like in letter C, right, we have a trinomial times a binomial. That's annoying. Okay, so something like that, a rule like the product rule, just makes it a teeny bit easier. Okay, so let's look at C. All right, C is annoying, like I said, because you have that trinomial in there. So if you wanted to multiply them out, pain in the hiney. But let's try our little trick here, our little rule, right? The derivative of the first, well, that's easy. That would be a 2 times the second, x squared minus 2x plus 3, plus the derivative of the second. All right, so I'm going to get a 2x, right, from here, and then minus 2, right? The 3 goes away, times the first guy, 2x plus 5. So, yeah, annoying algebra here. All right, looks like I get 2x squared minus 4x plus 6. And then when I multiply this out, I double distribute. 4x squared plus 10x minus 4x minus 10. All right, so grand finale, let's check it out. Y prime equals, let's see, 2x squared and 4x squared is 6x squared. You have a negative 4x, a negative 4x, and a 10x. That's going to give me 2x in the end, positive 2x. And then a 6 minus 10 is minus 4. And that, loves, is the derivative. So now, look at this. Now we bring in trigonometry. And I'm going to let you in on a little secret. When I took calculus, I don't know if I just wasn't paying attention when they talked about derivatives of trig functions. I don't know. It must have been in La La Land. But what happened was I just never got them straight. So I was always behind the 8 ball. So if there's one thing I can give you guys as advice that I would give to my younger self, it's to memorize the derivatives of the trig functions, which is in this little box. Okay? So I'm going to tell them right now. I'm going to set them up for you. Ready? I'm going to do it in pretty pink. All right, the derivative of sine. So y prime, the derivative of sine is cosine x, right? Derivative of sine x is cosine x. Now, be careful. The derivative of cos x is negative sine x. And then the derivative of negative sine x is negative cos x. And the derivative of negative cos x, I don't know, you guys want to take a guess? Yeah, it's sine x. Okay? So you got to just remember those, okay? Because if you don't, you are going to get eaten alive. All right, so letter D. We have the product rule here, right? X squared is your first function. Sine x is your second function. All right, so in order to do the derivative, right, we're going to use the product rule. Derivative of the first, 2x, times the second, plus the derivative of the second. All right, the derivative of sine is cosine of x times your first function, x squared. All right, let's clean it up. Let's see. 2x sine x plus x squared cos x, if we put it in a little bit better order. All right, what we're going to do is, this is a little weird. You could take out an x, and I'm talking about not from this x or this x, but a GCF of x here and here. So you could take out an x, so y prime equals x, and what that will do is get rid of this x here, so you'd have 2 sine x plus, taking out an x here, x cos x. All right, I'm pretty sure you could leave it in that purple like line in the middle, but just in case, you know, these are things, like I said, it's an algebra course more than anything. You start pulling back factoring again. I mean, I know you hate factoring, but it never, ever goes away. All right, so I know that the second page is a whole bunch of practice problems. So I'm gonna pick some hard ones to do with you. And then I'm gonna kind of fill in the rest of the ones that I don't do, and I promise I'll post the keys so you can practice. So I do think A is pretty easy. Let's go through B for a second. All right, I want to go through B. Right, so this is where I have an F prime, look. And I have an F prime because of X, because I have F of X here. All right, so just a little different notation, but technically the same idea, same meaning. All right, so derivative of the first, so derivative of 3x plus 2 is 3, times the second, cos of x, right? Plus the derivative of the second. All right, so derivative of cos x is negative sine x times the first. All right, there's not really much you can do here to clean this up and make it look nice. I think I'd make it 3 cos x, no need for the parentheses. Just minus sine x, parentheses 3x plus 2, right? I wouldn't have plus signs. So this is just making it look a little nicer. You're not doing that much there, though. All right, let's look at one that you might have some trouble with. Let me see. C doesn't look too bad. Well, D is a little annoying. All right, so we're going to mess with D. Oof. This is a little ugly. So we're going to try this together. First thing I'm going to do is I am going to rewrite this. I'm going to make it y equals, I'm going to trade in that radical, x to the 1/2 times this x squared minus 3x plus 2. All right, so here we go, y prime. The derivative of the first. All right, drop that 1/2 in front, x to the, remember, 1/2 minus 1 is negative 1/2. All right, derivative of the first times the second plus the derivative of the second. All right, so I'm taking the derivative here. 2x and then minus 3 times the first. Oof. Yeah, I don't really think I would do much to change this at all. I think I'd probably leave it like that. What could we do? We could drop this x to the negative 1/2, put it in the bottom, over 2. So kind of, let's just talk about this for a second. Remember, this is 2 is on the bottom anyway from 1/2, right? 1/2. This would be x to the 1/2, and you'd have x squared minus 3x plus 2. And then plus, I mean, what could you do here? You could bring this x to the 1/2 in front. I'll show you why in a sec. Times 2x minus 3. Last thing I would do is change in the 1/2s for radicals. So I would get rid of that 1 up top in the numerator. X squared minus 3x plus 2 all over 2 times the square root of x, because I traded in 1/2 for the square root, plus the square root of x, change that, times 2x minus 3. Honestly, I'm hoping you could see this all. That's like as good as it gets. You know, it's ugly. Would we have to, I don't know, combine? Probably not. What I do have to tell you with the AP Calc, it seems like they have mercy on your soul at some point. But to get from, you know, here to here, even to here, I mean, that's good. You could probably leave it like that. Like I said, it all depends on the context of the problem. All right, so let's see. Yeah, let's, yeah. I'm gonna call it quits here, and I'm just going to set up the rest of the answers, and I will take a picture and post them with my notes. All right, so again, have a great day. Enjoy. There's another sheet, right, that has a whole bunch of practice problems, so make sure you you work that out, okay, and check your answers and reach out. The answers again are also on that PDF. Just scroll to the next page. All right, bye guys. Have a great night.